Today is 8th grade, Chapter 3, Lesson 1, Constant Rate of Change. But before we discuss that, let's go over the 7th grade lesson, which you'd find in your notes on page 12, 7th grade notes, page 12. And it's Chapter 2, Lesson 1, Unit Rates. Example says, Store A offers 4 CDs for $60. How much would one CD cost? A rate compares two types of units. And a unit rate is a rate that is simplified to a denominator of 1. So when they ask you how much one thing is, that's unit rate. Like in this example, they want 1 CD. So a unit rate is a rate that is simplified to a denominator of 1. So we want to find out how much 1 CD cost. When we compare things, you usually write them like fractions. So $60 for 4 CDs. And we're just simplifying that to 1. So I want to change 4 CDs to 1. So I would divide by 4. And if I do that on bottom, I'd have to do it on top. And 60 divided by 4 makes 15. The unit is CDs. That's the thing that turned into 1. And the rate is $15 per CDs. We compared the cost to CDs. Example 2. Store B offers 6 CDs for $75. How much would one CD cost? So we have $75 for 6 CDs. And again, we want to change that to just 1. So 6 divided by 6 would get me 1, so I'm going to divide by 6 on top. 75 divided by 6. And this is money, so we're going to change it to a decimal, not a fraction. And since it is money, we want 2 spaces after the decimal, not 1. And I would get $12.50. So the unit rate is $12.50. Which store is a better buy? That's usually the question they ask, not what is the unit rate, but which is a better buy. And better buy, for math purposes, is cheapest. So which one's the cheapest? Store B, because it's $12.50. So 8th grade, Chapter 3, Lesson 1, Constant Rate of Change. Now that you know that a rate compares to units, we can talk about a constant rate. The time to download songs from the internet is shown in the table. So the top one is our X, and the bottom is our Y. X is talking about time, and X is usually the time, whether it be minutes, years, or months, or hours. And Y is the one on the bottom, number of songs. What is the rate of change? Well, to find the rate of change, just like we did, 2 songs, I'm just picking one, 2 songs per 1 minute. Remember, unit rate is for 1, and that was where the 1 was. You can also write it like a fraction, 2 songs per 1 minute. And then we're going to graph the ordered pairs from the table, and we're going to label the axis. So X goes across the bottom, and Y is going vertical. So our X was time in minutes, and the Y-axis was number of songs. And the first one said 0 minutes, 0 songs, so we're going to put a dot there. The next one said 1 minute, 2 songs. The next one said 2 minutes and 4 songs. So I'm going to go over how many minutes and up to how many songs. The question asked, at this rate, how long would it take to download 9 songs? So I hope you've noticed there's kind of a pattern, made kind of a straight line. So let's use our graph and find 9 songs. I'm going to go up to 9 on the songs and then over. If our pattern continued, if I connected those dots, let's see if I can do it straight, about where would it cross the 9 songs? Kind of right there. That would be about 4.5. So it would take about 4.5 minutes to download 9 songs. The relationship that have straight line graphs are called linear. Linear means line. So if it's a straight line, like our little blue line right here, then it is called a linear relationship. This is because the rate of change is constant. It's the same price or the same time every time. Example says label the graph and table as either linear or not linear. I'm going to look at the graph first. The graph, if you connect all the dots, makes a straight line. And if it makes a straight line, it is linear. However, if you don't have a graph to look at, you're going to have to compare. Pick 2 points and 2 other points. They have to go together. And we're going to subtract we're going to put the y's on top and the x's on bottom. So on top, we're going to subtract 165 minus 143. And on bottom, the number that went with 165 was 10. And the number that went with 143 was 20. So we're going to do some subtracting. 165 minus 143. 22. I ran out of room, so I'm going to put it down here. 22. And 10 minus 20 would be negative 10. And if I change that into a decimal, 22 divided by 10 would be negative 2.2. And then I want to check these and see if I get the same answer. If I get the same answer, then it is constant. So again, put the y's on top. So 123 minus 99, and x is on bottom. The number that went with 123 was 30, minus 40, and 123 minus 99 is 24. 30 minus 40 is negative 10. And if I divide 24 by 10, I get 2.4. And those are not the same number, so it is not linear because it is not constant. It has to be the same number each time. Let's look at the worksheet you're supposed to do, Chapter 3, Lesson 1, Independent Practice. And for the first four, the directions say determine whether the relationship between the two quantities described in each table is linear. If so, determine the constant rate of change. If not, explain your reasoning. So if it's linear, we have to tell what the rate is. Number one, we're looking at hours spent babysitting. And remember, time is usually the X versus the money they receive for babysitting. So that's the Y. And what we're trying to do is see if the Y is changing by the same amount and the X is changing by the same amount every time. And that little triangle is called a delta, and it means change. So that's a short way of writing change of Y over change of X. And when we did the examples, we subtracted two numbers. You can do it just over here on the side. So 10 minus 30 is plus 20. So each time it looks like we're increasing by plus 20. So the Y's are changing by 20. And every time it looks like the X's are changing by 2. So the X changed by 2. Since the amount was the same every time, I already know that this is linear. I need to simplify that. So it's an improper fraction. 20 divided by 2 makes 10. And for it to be a rate, you've got to use words. So don't just write the number, write 10. And it's money, so $10 per, got to have that word, hours. So $10 per hour, because you're trying to find out how much they get for just one. So on all of these, you're going to be checking to see if it's linear. And if it is linear, then you have to write in words the number, per, and then there's just other describing words. So if this number 2 is linear, it would be something magazines per student. And number 3, it would be some number apples per tree. And if number 4 is linear, it would be a number degrees per minute. Now, number 5 and 6. We haven't really talked about proportion yet. We'll do that later in the week. You can see from the graph that they are both linear. Linear means that they made a straight line. But to be proportional, it also has to go through the origin, which is 0, 0. 0, 0 means you went over 0, you went up 0. It's origin. It's kind of where it starts, right here in the corner. And this one on the left, number 5, does not go through the origin, so it is not proportional. And our reason is because it does not go through 0, 0. Number 6 does go through the origin, and it is a straight line. Has to do both. Go through the origin and be a straight line. Since it does both, this one is proportional. And the reason is because it goes through 0, 0 and is a straight line.